Tonight we have Steve Kennedy VK6SJ. I'm
Six.
Sorry, I was just about to say I need my glasses on to read this properly.
Yeah.
Licensed since '81 and the principal of Future Systems, DX Radio Systems in Perth. They're distributors of ANZ through Australia and New Zealand for Flex Radio, and dealers in Code and ICAM, Benelec, Hustler, etc. Steve's online presentation will focus principally on ideas around the club remote station, but I think he's going to be happy to explore the Flex as well. So without too much more fanfare, Steve, I'll hand it over to you. And again, a hearty welcome. Thank you for making time for us this evening.
No worries. My pleasure. Right. So thanks for inviting me this evening. Nice to make the trip over from Melbourne, from Perth. This presentation will be split into two sections, really. The first is really just around remote club stations and remote stations in general, ideas. It's not a hugely technical discussion. It's more about the benefits of it and how you might go about organising something like this, throwing some ideas that you might want to think about. And the second half of it is around the Flex Radio, and we can pretty much take as much time as we like on any of them. If you're more interested in just talking about remote stations, that's fine as well. Yeah, so I'll start with the first half of it, club remote stations. Right, where are we? Okay. So remote stations. Why have a club remote station? I mean, most suburban locations have too much man-made noise for HF communications to be successful. These days, a remote station can be controlled from the suburbs, but be located in the country, and it's quite easy to do these days with just about every brand of radio. The good thing about doing it within a club is that you can share the costs out over a much larger amount of people, and you can also look at there's other means of financing a club remote station that's not necessarily available to just a small group of people or a person on their own. And obviously with more people, maintaining a site like that can be a lot easier as well. Generally, most club-owned remote stations are using people's own call signs rather than a club station call sign. It's a lot easier to do these days. There's plenty of ways of managing a remote station now that pretty much anyone can do it. And clubs can apply for funding for a facility. That's some ideas that the clubs that I've been involved with or seen have done applying for lotto grants, and you can get quite reasonable sized grants. I know Northern Corridor Radio Group, when they applied for a lotto grant for their remote station a few years back, got about 15 or 16,000 out of it. Local government grants, royalties for regions if you're outside the city. And property developer grants is something that I know NCRG's used quite successfully and probably gets 2 or 3 of those a year, and they're usually around the $1,000 mark. And raffles are the other one that are definitely worth looking at. Fairly easy to put together, usually pretty popular with the amateur fraternity, and can be quite profitable for the club. Why have a club remote station? Any member can start competing with the big guns in DX leaderboards, DXCC rankings, etc. As a club, I'm not sure if you guys are aware of it. I'm not sure. Actually, I think you might already be on it. The WIA DX leaderboard, which is part of their DXCC or DX awards scheme, actually have a club section where individuals can tie themselves to a club, and their score, as well as going to their own rankings, etc., can also go to an overall club ranking. I know NERG are featuring pretty well in that, I think, at the moment. And you can compete in contests in multi-op categories from home, which is probably something you guys haven't done for a little bit during all the lockdowns and that you guys have had. If anyone wants to ask questions, I'm quite happy to take them throughout the presentation or at the end. I'm happy either way. Things you need to think about: antennas, obviously. Directional antennas require remotely accessible rotators. There's quite a few options for those around. What I've always used is a green heron rotator controller. They work with just about any. I don't know of a rotator that they don't work with. So very flexible in that regard. They're easy to connect to a computer, and there's a whole bunch of ways, easy and more complex, to control them. In the early stages of putting together a remote station, verticals are also a good way to start, particularly for the lower bands. You're generally ground mounted, so you don't need masts, you don't need rotators or anything like that. So they're worth looking at as an initial starting point for a remote station. Broadband dipoles, another way of getting on air fairly cheaply and quickly. Other things you need to think about are antenna switching. If you've got like an SPE amplifier, for instance, that's generally good for at least four antennas, and the software that controls the amplifier can also switch antennas. 6-pack, oldie but a goodie. The older 6-packs I don't think can be controlled remotely, but the newer ones are all LAN connected and that sort of stuff. Flex and 403 Alpha both have a one called the Antenna Genius, which is reasonably priced and quite smart, and it's a LAN connected as well, so it makes it very easy to control remotely. Power supplies. If you can stay away from solar, it's probably a good idea, particularly if you're using amplifiers. Simple solar powered sites can be built if amplifiers are not required, but finding a DC capable amplifier can be a bit problematic. I've done one 48 volt DC site that used an amplifier, but it was a Codan amplifier, and it was quite expensive. Certainly a lot more expensive than even the top of the range ham amplifiers. And you need to be able to remotely switch the most of your equipment off and on. So you need to be able to isolate power to equipment as well as being powered by the power supply. Security. CCTV is pretty easy to do these days. You've probably got CCTV in your club station now. Most cameras are IP connected these days, and there are some pretty affordable monitored solutions around. In the order of sort of $20 or $30 a camera per month type thing. Or you could just use a reasonably rugged outdoor cabinet with good quality locks, and just hope that they can't get in. Amplifiers, hard but not impossible to do with a solar powered site. As I was saying before, you need to be able to monitor the amplifier. Some amps are better at that than others, but most solid state amplifiers manufactured these days have a means of remote monitoring of some sort, even if it's just to a local computer. Connectivity. 4G services are convenient, but you quite often need a fixed IP address for a remote station. Telstra have some pretty good and pretty easy to get services for that kind of thing. Extranet, I think it's called. Or you could use tunnel routers, where you still need a fixed IP address, but it could be in someone's house, and as long as you've got one fixed IP address in the network and your master routers at that point, then you can run a tunnel router. But the problem with that is that you then need tunnel routers at all your members' places as well, which can get a bit expensive after a while. NBN cabled internet connectivity is obviously should be your first choice, really. Radios, Flex 6000 series radios are obviously a great choice for remote operation. I'll show you a little bit more about that a little bit later. Having said that, though, most radios manufactured in the last 10 or 15 years have got PC connectivity. And if you've got that, then even if you need to have a PC or a Raspberry Pi or something on site, you can connect it to the internet. There's plenty of software around for doing this kind of thing. Remote hams is a pretty common choice. That's a server that's, I think, free to use, and it allows you to control access to the site quite nicely. You can, and I believe you can also control things like how much power someone can put out, depending on their license and that sort of thing. You can, or you can at least prevent certain people from using an amplifier, for instance, if they're a foundation license holder, for instance. You can also configure it so that other people outside of the club can not have access, or they could have listen-only access, or you could give them full access, and it's all configurable as well. So remote hams is a pretty good choice for a club station type thing. Examples of remote stations. A club station that I've been involved in. This is actually Northern Corridor Radio Group's club station, remote station. They're using remote hams, the RC Forbes system, and on HF they're using an IC7300 transceiver, which is pretty cheap and cheerful, but does the job nicely. They're using a 1K5 FA SPE amplifier, a Step IR 40 to 6 meter Yagi and green heron rotator controller, and they're using dipoles for 80 and 160 meters. That's a pretty effective station. It gets out well. They're only using it for voice. They're not using it for FT8 or anything like that. FT8 becomes a little bit more problematic with this kind of architecture. On VHF and UHF, he's again using the remote hams software, and they're using an IC9700 transceiver. They've got a azimuth and AL rotator, and they've got Yagis on 70 and 2 meters for satellite operation, and they've got a vertical for 23 SEMS. This is what the a typical remote hams user interface looks like. And to give you a bit of an idea on how hard this is to set up, I'd never actually used the Northern Corridor remote station, and I was putting together this presentation, so I rang up Tim, who manages it, and said, right, so how do I do this? And within 10 minutes, I was at this point here, and I could actually use the station. So it was pretty easy to set up, or pretty easy to use once it is set up, and it's got all your main sort of radio functions. This is just a screenshot, so I can't show you, but actually working. Station that I shared in building, and still building it. 4 of us just got together. One guy had a 5-acre block that he lived on, and it was quite quiet and in a really good location and not much noise. So it was like the perfect place to put the station. A couple of us had flex transceivers. I just happened to have for demonstration a Power Genius amplifier. We've got a high gain TH5DX tri-band Yagi up. We're using a green heron rotator controller and a 2800 Yaesu rotator. We currently connect to it via AnyDesk. I'll show it to you a little bit later. But we've got it connected to a Node Red Raspberry Pi based system that probably after this weekend we'll connect to through a web browser rather than using AnyDesk. And we've got a set of dipoles for 80, 40, 30, and 17 meters, and we've got an ultra beam vertical ready to go up as well. We've also got an ACOM A2000 amplifier. So all this stuff, none of it was bought especially for the station. It's just 4 of us pooled our resources together and put it together. So I think Barry had 2 decent sized masts that had come off his farm when he sold the farm to move back into the city. So we spent Christmas putting one of those up, and so the whole thing's been put together with what we've already got. So it's been quite cheap to put together. This is the user interface for the Flex iteration of it. Flex Radio has a server and a system called SmartLink, and basically you connect the radio to the internet, and you connect your computer or a Maestro or whatever you like to the internet, and the two just connect, and it just works, and it works exactly the same way remotely as it would locally. We found this is very very usable for 4 of us, but for a whole club, if you were just relying on this, I think it would probably start to become a little bit unmanageable in that it'd be hard to control access and things like that. So for a club station, I'd probably be tempted to use a Flex Radio still, but probably via the remote hams server rather than with SSDR. This is our web page for the Green Heron rotator. This is a bit out of date now. I'll just see if I can put up our current node red. So this is actually real time, our user interface. So we've got, this is a bit of an interim thing. I'll just get rid of that. So all the amplifier specs are here. We can do things like monitor the forward power to make sure we don't exceed 400 watts, which we'd never do, of course. And SWR, keep an eye on the temperature. They're the main things that we're worried about. You can control a fan speed here. And then this part's still work in progress, but you can see who's on the radio. I'm about to kick him off in a minute. And then the actual rotator, so you just click on wherever you like, and it just shifts the rotator around. And then we put this thing, which is pretty cool, the solar data is just all in there because it's nice and handy. And then we've got other pages for the Flex 6400, which we're still setting up, and station info. We've got a means of isolating the radio and amplifiers and resetting them, which you need to be able to do to save yourself a trip to site. And there's other stuff that we're putting in there as we go. We've only been building this for about 3 weeks now, so it's very much a work in progress at the moment. So I'll just hop out of that. So that's pretty much the end of, I guess my main goal from this is to get everyone thinking about remote stations, hop out of the mindset of, remote stations are only for rich people, and think about how you might be able to put something together either with a group of you or with your club in general. It's definitely a good way to go from like a simple vertical on a country location with a low noise floor is still going to be better than a Yagi in the suburbs, most likely, just purely from a receive perspective, at least, just because of the site itself. So it's definitely worth thinking about. Did anyone have any questions? It's probably a good spot to stop and talk about this side of it.
Do you have any comment about lightning?
Lightning, yes, that's a good point. I'm actually in the middle of writing a blog on that whole subject. You definitely need to think about lightning protection, and earthing of a site is reasonably important for lowering the noise floor and all that sort of stuff as well, and also for reducing the likelihood of being hit by lightning. We've certainly we've got earthing on our mast, and we're using LDF 450 heliax from the antennas to the shack, because we've got about I think thinking about 30 or 40 meters between the antennas and the shack at the moment. So we're using surge protectors in a location cabinet at the base of the mast, and earthing kits on the old F450, and they're all worthwhile things and not particularly difficult or expensive to do.
Presumably, with only one radio, you can only have one person using it at any one time. How have people gone with actually managing that within a club situation?
NCRG doesn't seem to have had too many issues like that for theirs. It was probably, particularly early in the early piece, it was probably the most popular facility in the club. We didn't have any rules like around the use of it. We just, we just figured if there was an issue, we'd deal with it when it became an issue. And as far as I know, there's not been any issues like that. There's a chat section on remote hams so that you can log on and say, oh, can I get on as well? Or, I wanted to work a station, particular station. Do you mind if I take the remote over for 5 minutes and work them, and things like that? And that's worked quite well. Probably the only issue that I've seen with it is a couple of people started to get a bit bent up about how successful some members are in chasing DX with the remote station. So we ended up having quite a robust discussion about the ethics of using the club remote station with your own call sign. I got my view on that. I think I think any activity on air is great, and I think it'd be hard to be motivated to chase DX for a club call when it's not contributing to a certificate on your own wall. So that's in the little group we've got with 4 of us. We're actually even now starting to get a bit congested, which is why we put a second flex radio in. So we've got a 6700 and a 6400 in a 19-inch rack, and we're still yet to implement the 2 of them together. We're going to use one of them for low band use, as in 30 meters and down, and the other one will be for 20 meters and up. And we think then it'll be manageable. And but like all things, it just requires everyone to be polite and respectful of each other. And we've got a little agreement that if someone wants to get on and someone else is on, we shouldn't be frightened of piping up and saying, can I hop on? We've got a little messenger group between the 4 of us. If you don't feel empowered to pipe up, then eventually it's going to, people are going to get annoyed with it. So we don't want that happening. So we've always said, just speak up, because if we don't, for me, certainly I could quite happily spend a whole evening, working a bit of DX on 15 or 20 meters or something, and but I'm just as happy to stop and get off for someone else if they want to hop onto it. So yeah, that's sort of how we handle it.
Thank you.
Any other questions?
Yeah, Steve, I'm more interested in accessing my own station from overseas using a computer.
Sure.
I've done it before years ago using a PIG remote. It doesn't seem to work anymore, but I'm just about to use an IC705, set that up. But the one thing people might need to look out for is make sure they're not behind a CG NAT server with their ISP. That
Right.
can cause an issue.
Yeah, I've certainly with the flex side of things, the only issues I've had is I've got this, in fact, a little modem I'm using right now to access the internet. I tried to plug that into a flex radio. It just didn't work because I need a fixed IP address and stuff. It's probably similar to what you're talking about. But apart from that, it seems to, the only thing you've got to do is open up some ports on the modem that the flex uses. In terms of other, you definitely need to look at your ISP, but with remote hams, it seems to be pretty, like I've not heard of anyone having too many issues like that. Operating your radio remotely, remote hams has got a pretty good system for that. ICOM have got a system. I've got a copy of it. I just haven't got around to trying it out. I I have given it to one of my customers just to have a play with. Unfortunately, he's an ICOM and a Flex customer, and in the end, he decided to put a Flex out on site instead. But you know, the 705 connects to a computer. You can, if it connects to a computer, you can use remote hams, and it shouldn't be too difficult an exercise. Any other questions? Okay, I'll move on to the next section, which is really focusing on the software-defined radio technology in general, and then we'll sort of dive into the Flex 6000 series radio. So I don't know how many of you are familiar with SDR technology right now. It's becoming more and more mainstream. I know I remember putting one up for a raffle prize in, it would have been about 2017, I think. And the year before that was the 7300 we used, and the raffle sold out in no time. And we were scared of not selling enough tickets to pay for the radio when we did the a Flex 6400 for a raffle prize, and I heard comments like, you know, I'm not buying some stupid computer radio and things like that. But I think it's everyone's sort of realizing now that software-defined technology is you know, with us and not going away, and whether it's hidden behind a normal user interface or whether it's a computer application like the Flex or an AND, it's they all work exactly the same way. So basically, a software-defined radio directly converts RF to a digital stream. So it's analog to digital conversion. It then processes the data to form intelligence. Predominantly uses a PC, either an external PC or one that's inside the box. And the PC is either a detailed user interface or it's embedded in a digitizing process, or both. Who makes SDRs? This is a little bit of an older thing. There's probably a few more around now. Softrock, Apache Labs, ELAD in Europe, I think, ICOM, Yaesu, both their current or newest models, they're all software defined. Flex Radio, obviously, and there are plenty of others as well. More and more coming on the market all the time. Approaches to SDR technology. So the old, this is the first ones that you would have seen come out, including the Flex 1000 and those sort of radios. PC sound card based, A to D and D to A conversion. So using a PC sound card to actually do that conversion. Used by Softrock and other simple QRP receivers and transmitters. Cheap and cheerful, and it's really good for learning a technology. And not only can you use it for as a radio, but I don't know if any of you have got FT2000 transceivers. They're a pretty popular Yaesu radio. They had a DMU box that you could connect a display into and have a pan adapter and all that sort of stuff. This is before radios came out with pan adapters, and I started to build an SDR receiver on 10 megs that was going to do the same thing from an IF output from the radio. So you can use a SDR as a pan adapter for a more standard radio. Next one is where A to D and D to A conversion is carried out in the radio, but all the processing is carried out by the PC using an application. This is what's used by Apache Labs, and the earlier versions of the Flex or earlier Flex radios also use the same thing, the 1500 and 3000 and 5000 series radios, if any of you are familiar with those. The software is evolving. Power SDR was what was developed by Flex, and then used a sort of open source software for lots of other types of radios, including the Apache Labs. Flex don't maintain that application, but there's a bunch of volunteers that do. It's there's other open source software to do the same job, and it's very much in the spirit of amateur radio, yeah, in terms of sharing ideas, experimenting with new technology, and all that sort of stuff. Then you got A to D and D to A conversion and the processing all happening in the radio itself, as in, and the user interface embedded in the radio. So you've got an FPGA processor, which is much more reliable and better at managing that data than a standard PC. Typically not no way for a user to be able to continue to add features to the radio, and it's pretty much how most ham radios and most commercial radios these days are being designed and built. This is like your IC 7300s and the 7610s and the new FT101D radios are all this sort of thing. And if you ever opened up took the cover off any of those radios, you'd notice that there's a lot less stuff in there than you're used to seeing in a ham rig. Then you've got the A to D and D to A conversion and processing carried out in the radio with the PC or external console just purely as a graphic user interface. This is how the Flex 6000 series radio works. It's a lot more powerful and robust. There's a lot less IP bandwidth required between the radio and the PC. I don't know if anyone's ever tried to run like an Apache Labs or an older Flex radio remotely, but you pretty quickly run out of data, or you run up a big bill, or the thing just stops working pretty quickly because of the sheer amount of data that needs to flow between the radio and the computer. With the Flex 6000 series approach, it's just a GUI, it's just a user interface. A meg of download is all you really need. And you can even use it with a phone or a tablet. I'll show you that a little bit later. So why might you look at the Flex 6000? Flex 6700 is up there. For a long time, it led the pack in receiver specifications, and it's only been number two quite recently, and there's not much in it. It's got a growing market share, which is allowing development of the product. There's a team of engineers working on the product in Austin, Texas. People continue to buy radios, and then they purchase the major upgrades that have come out a couple of times since they started the 6000 series radio, and all of that helps to fund continued development of the radio, and great value for money when you compare it with a high-end superhet radio. So Flex 6000 series radios start at about, just trying to think, just over the 4,000 mark, I think, and go up to about 12,500. But if you look at the list price of the top end ICOM radio, it's up around the 20K mark, and most of the others are sort of 15 to 20,000, and none of them are particularly better than a Flex 6700, for instance, and with a lot less features. So yeah, there's a Flex radio there for most budgets. You can get APIs for the radio, which allows third parties to develop applications and to experiment with different modes, etc. It's very, very easy to use as a remote station. It's so easy to use. It's not funny, and it's very flexible in terms of using it for contesting and digital modes and things like that. For contesting, I personally think it's got no equal. It's got a whole bunch of really neat features, like putting spots up on your screen, and that can be color coded by N1mm or something like that to show you which spots are new multipliers and that sort of thing. So it's really quite neat. Latest major version of the the software that's used for the Flex 6000 series is version 3. Caters for dual control, so you can 2 people can operate the radio at the same time, or at least receive on the radio at the same time. Bandwidth requirements are fairly low compared to others, which means that you can use apps on an iPhone or an iPad to access the radio quite successfully. And this version 3 was specifically designed for remote and multi-operator access. With most of the other software-defined radios, apart from EASA and ICOM, etc., a lot of the power Sdr and those sort of applications that are used to run those radios are almost crowd-based sort of things. So they're only successful when you've got volunteers that are willing and able to work on it. Flex radio have sort of got an approach that's a lot more commercial based and it's sustainable. So the radio continues to evolve. The 6700 I have was originally bought. It was one of the first 6700s to come out. So it would have been bought in probably 2015 or 14 or something like that. And it has exactly the same features as one that I sell today. There was absolutely no difference between the two radios. And the cost of that has been 2 lots of $200 for version 2 and then version 3, which typically come out every couple of years, which is a lot cheaper than trading your radio in for a new one. Yeah, so new software has always been developed, and a great hard console. Flex have had the Maestro for quite a while, but the one that's coming out in the next any week now is quite a lot improved on the old one, and it's worth buying in my opinion. Now we've sold very few of them beforehand, but this one I think we'll sell quite a few of. But there's nothing stopping you from making your own. You can get the API from Flex; it's freely available, and lots of people have built user interfaces out of MIDI consoles and stuff like that. Other advantages of the Flex radio side of things, I'll show you this in anger shortly. But integration with other software packages like HRD and N1MM, etc., is really easy. You can connect as many serial connected devices to the radio as you want, and there's the full suite of functionality is available across multiple receivers. The cheapest model has 2 receivers, and the most expensive has 8. So 6000 series, they're all 100-watt transceivers, HF and 6 meter coverage with the 2 meters available on the 6700 model. Although that is only about a milliwatt or something like that output, it's designed for a transverter. They operate under a program called Smart Sdr, which is maintained and managed by Flex Radio. It can be operated with the Maestro Console, which is like a hard console. I'll show you a picture of that in a sec. Currently ranked number 2 by Sherwood Engineering in the receiver dynamic range performance, which is probably the most important specification particularly for contest operation. The 6700 is capable of full duplex operation, as is the 6600, and it's capable of D-Star and digital voice. 6400, this is our entry-level radio. So 100-watt transceiver, 2 pound adapters. It was about 3,500, it's now about 4,000 Australian dollars. There's an optional ATU. You can span across up to 7 megahertz of spectrum, and that's configurable from the user interface, and that's per slice. So you could do that twice on 2 slices. Flex 6600 transceiver. This is the one we sell the most of. 4 pound adapters, as in 4 receivers. Around 6,500 to 7,000. Can't remember exactly how much. Has an ATU standard. 14 megahertz maximum spectrum. double the sampling rate of the 6400, so makes for better performance, and as an external 10 megahertz reference input for more accurate time base, and multiple amplifier keying outputs. It's got a front end pre-select filtering, additional to the other what the other models of radios have, and there's 2 spectral capture units, which are the devices that capture the RF and turn it into a digital stream. That allows you to do full duplex and to have completely independent receivers. So you could have one antenna connected to one spectral capture unit and the other connected to another one. And so if you've got 2 people using the radio at once, providing they don't want to use the same antenna, they can actually use 2 separate antennas completely independently. Right.
Hey, just one quick question. With remote
Yep.
use in these, is there any latency problems with CW and digital modes?
That's a good question. We've got a fiber to the home at the remote site. So we've got a good internet connection at the site. To me as a user, I can't really see any, it seems to work perfectly fine for me. Certainly don't have any noticeable lag. I have had people ask me if I'm using a remote station, and the reason I've asked is because there's been a slightly longer lag between when they finish talking and when I start talking. So they probably notice it more than I do. It's a bit like using a sat phone. The user of the sat phone doesn't really hear any different because his audio coming in is also delayed, but the person on the other end notices it more. But I've noticed when I'm doing contesting, I tend to start responding to someone calling CQ just before they finish, sort of thing, so that I can get in really quick. But apart from that, it's not noticeable and not something that gives me grief unless my internet connection starts to drop off a little here at the user end. But as long as I've got about 1 meg of download speed, which is pretty slow these days, it just works perfectly. Right, back to this Flex 6700 transceiver. This is our top of the range radio. It's around the $12,000 mark. It's got 8 PAN adapters. You can actually connect 8 instances of WSJT or something like that to 8 separate receivers on 8 separate bands, and have them all working completely independently. You can only transmit on 1 slice at a time, but you can receive on them on 8. It also has a 2 meter capability. It's a bit smaller than the 6600. This is the old form factor that the original 6000 series radios came out with. A little harder to work on in this form. Maestro Console, this is around the sort of $2,000 mark. And it's for those people that must have knobs. It comes with its own little 8-inch screen, and most of the sort of basic functions that you need on a radio are all there. It can be wirelessly connected. It's also got an Ethernet port, so it's quite easy to use remotely. You can take it with you on a trip or something like that, and use it. And you just, all you need to be able to do is connect the Maestro to the internet. So if you've got hotel Wi-Fi or something like that you can connect into, then it'll just work. So very, very handy for that type of application. Me myself, I'm more of a computer kind of user. I'd much prefer the form factor in the SSDR app running on my computer, and I use my work computer for my home for the shack as well. So yeah, using the radio while I'm working away is no different to using it at home. They're both remote operation. Big Boys Toys, Power Genius, 1.5 kilowatt amplifier. It'll do 1.5 kilowatts day in, day out on FT8 if you're allowed to. It's fully integrated with the SDR software. I'll show you that shortly. It's got two completely isolated and separate inputs and outputs. Still only one amplifier, but you can transmit, 1.5 kilowatts into one antenna, and the other port will be 70 dB less than that. It's true single operator 2 radio operation, and if you've got a Flex 6000 series radio, the only thing you need connected between the radios, apart from coax, is a LAN connection, and that's it. This I've been using this amplifier since December, and I've got to say I love it. It's just I've had a few solid state amplifiers, and I've used quite a few. NCRG has a 2K FA amplifier, and with that one I found that particularly if you accidentally, of course, operated more than 400 watts, and you had an SWR of like 1.5 to 1 or something, it'd start tripping out, which is really annoying. This radio will work quite comfortably up to about 2.5 to 1 SWR, and it's got a harmonics dummy load in it, which is good for 400 watts, which will funnel off any harmonics and also reflected power, I think, into a 400 watt load instead of back into the amplifier, and makes it a lot more robust, and it doesn't it'll trip out if you go well over 2.5 to 1 SWR, but apart from that, it just seems to work really well. So I've been really happy with this amplifier. I can't wait for us to get some to be allowed to use it a little bit more. USB tuning knob. This is a really good little device. It plugs into your computer that's running SSDR, not into the radio itself, and it gives you a VFO knob, and you can configure these 3 buttons above the knob for a whole variety of different things. I use auxiliary 1 for PTT. Saves me bothering with a PTT switch going to a serial port and that sort of stuff. So for remote operation, I find it quite useful. And it's also focused only on SSDR. So you could be typing a call sign in on your logging software, and this device still controls the radio. Whereas if you're using a mouse, for instance, for everything, then you've got to swing your mouse from the logging software to the radio to make a change in the radio, which can be quite off-putting in a contest situation. So this is a really handy little device for that. They're about $280. They also work with power SDR. So if you've got a NAN, I've sold quite a few of these to people who've got a NAN transceivers that want a device like this, and it works just as fine with that as well. Okay, so there's two means of managing remote operation of a Flex 6000 series radio. Just circling back on that question about the latency. I know one a Melbourne-based ham who runs a remote station or two, and he's put a VPN in between his house and the sites, so that he can connect directly to the radio, not necessarily going through Flex Radio's SmartLink server. And that's reduced his latency a bit as well, which would be really good for contest use. And that's something I definitely want to do on our station, but it's probably a little bit further down our priority list. So the SmartLink server works on version 2 and version 3. I don't know anyone who still uses version 1 on a Flex 6000 series radio. SmartLink server is quite reliable, easy to use. You don't need a degree in IT to set it up. So simple, even a radio tech can do it. It works with Smart SDR for Windows, and also the iOS version that you use on either a Mac or iPhone or iPad. It's pretty intuitive to use, and you only need about 1 meg uplink bandwidth for it to work. And it allows exactly the same use of the radio locally as it does remote. 3 means of managing remote operation with the 6000 series radio. You could use third-party remote operation servers like remote hams. There's no reason why you can't. The radio still connects to the radio still has an interface that connects to computers just like any other radio. Flex uses the same command set as Kenwood does. You could use Smart SDR via SmartLink, which goes to the States and back, which is what we're using at the moment at my station. And it also allows connection of your CAT and DAX software, which is the virtual COM ports and virtual audio streams also go through that SmartLink server. So you can actually connect, you can have things like WSJT and HRD and all those sort of programs sitting on your local PC where you are, and it's connected to the radio via the server. So you're not trying to team viewer into a local PC that's on your remote site and operate that, which can be quite problematic and limit you to one screen only. Whereas, you know, if you've got all that stuff located at the user end, you can have multiple screens and all that sort of stuff quite easily, which is how I work here. And you can connect to it via a VPN, which will work exactly the same way as SmartLink. It's just you're connected directly to the radio. Operator basics. We've got pan adapters, produces an analysis spectrum adjustable from 1 kilohertz to 7 or 14 megahertz, depending on what model radio you've got. You can have between 2 and 8 pans displayed. You can also pull those displays out and put them on a separate screen, or you can have them all on one screen. So this is a single pan user interface. And if you look here, this is spanning what, 1, 2, 3 kilohertz of bandwidth. So this is typically sort of bandwidth you'd need for WSJT. And you can expand that up quite a bit further than that, so you can actually see individual signals within here. This is what it looks like with 2 pan adapters on the same screen. And if you've got a 6700, this is what it could look like with 8 pan adapters. Not something I've done myself, but I know a few customers of mine have bought the radio, the 6700, because it can do this. Slice receiver. Slice receiver is an independent receiver with its own voice stream and COM port, allowing it to be controlled and used by software packages such as logging programs and skimmers and stuff. You can have between 2 and 8 slices on one pan, or you can split it across multiple pans. Obviously, if you're trying to do 8 channels at once with 8 different pan adapters on 8 different bands, you can only have one slice on each because there is only 8. Each slice is completely independent of all the others, has brick wall filtering. So the filtering's super sharp and super square. If a signal's outside the filter, you don't hear it. It's really good for contesting, in particular. COM ports. We have this software called CAT, which runs in parallel with the SSDR, and you can assign multiple. You can assign COM ports to slices. You can have more than one COM port going to a slice to run more than one program. You can have separate COM ports going to different slices, so that you could have, for instance, JS8 call controlling slice B, and WSJT controlling slice A. That's something I have used in the past. Virtual audio streams. So this is the Flex 6400, which only has two streams. So you can adjust the RF gain on the stream. And this stream is like a like an audio cable coming out of the radio, except that it's all done across IP. iOS, using a iPhone or an iPad. I've used this quite successfully. That's my mobile radio of choice. Allows use of a pan adapter and most other functionality with smart Sdr, but on a phone or an iPad. Has a few additional features as well. DX spots was something that came out with the iOS version before it came out on SSDR, but now they've got both. And you can connect other devices like MIDI controllers and stuff like that, and these Flick Smart buttons, which are, you could put a PTT switch on your steering wheel of your car and stuff like that. Really good for casual use of the radio while you're away. And on an iPad, it looks really good. The user interface is a lot easier to use than on a phone. I thought I had a screenshot of. Oh, here we are. This is a screenshot of from an iPad. So you can sort of see it's reasonably uncluttered. All your controls are on the left and right hand side. You just sort of touch these, and it'll bring down your band switching and antenna switching, mode switching, and all that sort of stuff. That's just basically the user interface. Now, before we go to questions, I'll give you that's a bit of an old screenshot as well. I'll give you a bit of a look at a real station now. Hopefully, yep, I've got off it. So you can see here, this is the first thing that comes up when you run the SSDR. So we've got two radios connected to it. They've got 6700 connected and the 6400. Currently, that's undergoing a bit of development at the moment. Stu, one of the guys, is in the shack playing with it right now. So we'll connect to the 6700. Right, so this is, I'll just mute the audio. So this is the user interface in the radio. This is, let me just switch that WMB off. This is on 20 meters at the moment. I'll zoom right in. So that's the FT8 frequency on 20 meters, so you can see each individual. That's how far you can dive down into it. In fact, I think you can go even further. I think that's about it. You can bring it right up. So there you got bottom end is 7 megs and top end's 21 megs, so full 14 megahertz across it. Why you'd want to quite see that in a ham world, I'm not sure, but it's there to be seen. I'm just going to connect HRD to it. So, hang on a minute before we do that. Connect DAX. Connect CAT. Let's bring this over here quickly so you can see it. So Ham Radio Deluxe is just connecting directly to the radio now. I'll get rid of this logbook in a sec. So I've been having a bit of fun with this. So the logbook and everything's sitting on my PC, and it's connected to the radio remotely. So so the only thing that's on site really is the radio and the amplifier and rotator and all that sort of stuff, obviously. So you can see here I've got one stream running. I can adjust the level to suit the software I'm using. You can do the same thing on transmit for the transmit stream. Again, the data software, data mode software is running on my PC right here, not at site. So that decomplicates things quite a bit. I'll just run up N1MM. Hopefully we'll see some spots come up on it. If anyone's got any questions, just pipe up, because this is probably best to ask questions as we go. All right, so just move these aside. So this is N1MM. The only reason I'm running this at the moment is that it's got the ability to broadcast spots on a multicast address, and then what happens is the Flex radio actually monitors that, and we'll put it up on the screen. So I'm not quite sure why this FR stack is coming up. It's only happened today. But as spots come up, you'll see them appear on the screen here. So you can, and then you can just click on them like this FR stack. Okay. I think that's one of our, I can't talk about that one because I don't know about it, but I think that's something that Stewie's been playing with. So let's go to maybe 40 meters. Okay, so now you can see some of these spots coming up on the screen. You can just double click on it, and it'll just go to exactly that spot. Hover the mouse over it and you can see what was also broadcast with that spot. If we're actually in the middle of a contest, you'd see different color codes up here for whether it's a multiplier station or not, so that if you're running a second station just for multipliers, it just makes it a lot easier to identify and pounce on them. WSJT, I'll just run that up now. So I'll bring this across as well. No. There we go. So this is just all running, exactly how it does normally. So this looks exactly and feels exactly like if I was running the station locally. There's just no difference whatsoever. Some minor let me just probably still running on antenna 1 as well. Oh no, antenna 2. Yep. So WSJT is looking and exactly the same way as it would do if I was using it remotely. And I certainly don't notice any latency issues using this software locally. It seems to work perfectly. Every now and again, I've got to sync up my computer, but that's about it, really. Audio-wise, I'm not sure if you can hear this audio. Yeah. Can you guys hear that audio?
Yep, not a problem.
Yep. Okay.
Went home and went
so.
to bed, and I was all right the next day. But yeah, other people, sort of, yeah, I don't know. It's hard to.
So just to dive around the radio a little bit more. Some of the neat features. This tracking notch filter is pretty cool. Let's just dive down into that a bit. So if you've got a someone who's quite loud right next to you, for instance, you can actually notch them out. Let's just notch this one out. You move the mouse up and down. I'm holding the left button down on the mouse up and down, which varies the width of the filter. And then if you change frequency, sorry. No, there's two separate signals, but but so the notch filter will stay in the same spot, and you can move the frequency around a bit, so it'll continue to notch that signal out, regardless, as long as you've actually got track and noise filtered there. So let's just have a look. Probably what I'll do now. So if we dive into this a little bit, we could run a notch. It's actually not doing what it should be doing. What's going on here? Oh yeah, there you go. Yeah, so you can actually notch out a bunch of stations, and if you want that sort of thing. I actually don't use this an awful lot, but it's handy particularly in contest type operations. So we'll delete that and turn it off. Adding additional slice receivers, so you can, if you want to run split, for instance, it's pretty easy to do with this. Let me just zoom out a little bit more. If you operate split, then if you hit split, then it actually generates another. Let me just get rid of one of these. It'll actually open up a separate slice, so that you can move the receive frequency around, all that sort of stuff, same as you would with the second VFO. Take split off and it takes it off. You can move the transmit between different slices. So if we do another slice here, you can shift the TX from one slice to the other. Change all your modes here. This is all the modes that we've got available. Ready, digital FM, I guess that is. Narrowband FM, FM, stereo AM. Digital up and lower is for your digital modes, CW, and they're all pretty self-explanatory. You've also got your various filter widths that you can select. And you can also stick your mouse across that and vary the filters manually. I'll just show you this filtering again. So you can hear that filtering is pretty sharp. Next one is band. You can switch bands. There's one interesting thing here, transverter. By the way, this radio works on 630 and 2200 meters as well. Transverter. I haven't got any set up on here, but you can, let's just go and show you here, radio setup. Got a transverter. We'll call this one 2 meter. Make this one 28.1. No, RF frequency, sorry. 144.1. IF frequency 28.1. Allow it. Okay. So now when we go across here to band, 2 meters. So you can see here, the radio is actually receiving on 28 megs, but on the screen here, you've got all your your actual final frequency, and you just because it knows that you're using a transverter because you've set it up that way, and basically as long as you've got a local oscillator that's mixing with your 28 megs to provide your 2 meters, you'll have the pan adapter and all that sort of stuff that you enjoy on HF. You can have that on 2 meters or 23 SEMS or 10 gigs. So we'll just switch back out of that, back to HF. Antenna, there's 2 separate antennas on the radio, plus you've got receive antennas as well. So you can, on each individual slice, you can set whether you want receiver A or receiver B antennas, antenna 1, antenna 2, or the transverter output. In this instance, we've got a Wyndham antenna connected to antenna 2, which we use on the low bands. Display, this is all your, all this does is control the rate of, the average, the characteristics of the display itself and the waterfall, etc. I almost never play with that, but you can see here we bring this average down. You can see what happens when we play with that. DAX, you got 4 choices of DAX IQ channels, which allow you to put into I've never actually used this myself, so there's probably some people in the room that might know more about than I do. I think you can run this into like skimmers, CW skimmers and stuff like that, and other software that uses IQ streams. So you could connect something other than SSDR to it. I guess I'm not really sure. I haven't played with that too much. Up here, you can control on this particular slice. You can control the volume. You can have it coming across left and right speaker equally, or all to one side or the other. This is for AGC, so you can manually adjust the AGC, or you can set it off completely. I usually mine on medium, and you can have a sort of a diverse diversity. I think that's using, it's using, if you had 2 similar antennas on antenna 1 and antenna 2, you could actually receive over both as a diverse receiver. Not something I've ever used before. So you got a lot of controls up here that are all fairly sort of things you'd normally use on a radio, different noise blankers, etc. Mode, which we talked about before. RIT, pretty self-explanatory. DAX, because I'm using this at the moment with digital mode software, which has got a virtual audio stream connecting the audio from the radio to the digital mode software. I'm using DAX channel 1. So when you look at where are we? The DAX here, that's this stream here. So at the moment, this stream's connected to WSJT, and you can switch it off or on if you want. I normally just leave it on. So if you had JS8 call and a few other versions of software running, you could assign them to different streams on different slices, so that they all work independently. Across here, Power Genius amplifier screen, so all the vital statistics of that all work here. Where are we? Oh, amp's in standby at the moment. We'll just shift off here so we don't interfere with anybody. But you can see all the normal sort of stats from the amplifier are all shown here. You can show your active slice, comes up on here. This is your power out for the radio itself and SWR, and where you can connect the tuner. MOX, that's pretty self-explanatory, and tune button for just hitting the tune thing. You can adjust the power out and tune power. So obviously we would have that down here so we don't break the law. Or your audio side of things. So if I'll just switch this across to lower sideband. So you can see now here we've got any number of different microphone profiles. So I've got I'm using a PV12 studio microphone, which is probably about $50 or $60 from a music store. That's what I'm using for this presentation as well. And it's connected to PC. If I bring this down here, someone's been mucking around with that. Fair income. So this is normally set up for how I want it in my my microphone. And obviously someone's played with it, not realizing that it's affecting whatever's set up at the time. So this can be set up to be tailored for each individual microphone. I set this one up with a mate who's got a recording studio, and it sounds really good. It probably wouldn't sound very good in that sort of configuration there. You've got the same thing with receive. You can set however you like for the receive equalizer to make it sound how you like it. And then down here you've got all your you can adjust your high cut audio filtering. You can set up Vox, which I hardly ever use. Yeah, let me just go to here. Over here we've got profiles. So hopefully no one's mucked around with my profile. So if I go Steve SSB, this is my profile for SSB. Okay, so it's all set up exactly how I like it. And you can see here my microphone is set how I like it. I'm pretty sure that's how I had it set. And all the other things I like. And then when I've finished using the radio, I'll go and set this up for some sort of default, like maybe this one on a SO2R default. And when I do that, the next person comes in, he can do whatever he likes. He can play with it as much as he likes, and it's not going to affect me, because the first thing I'm going to do when I come in and use the site is, depending on what mode I'm going to use, I'll set my own profile, so that the danger of not changing the profile to the default one when you finish is exactly what I just showed you. Then someone else comes in and just plays around with it, and before they know it, you've all your settings are all screwed up. So what else have we got? That's pretty much down here you can select additional pan adapters. You can pop out pan adapters and put them on other screens. Let's put it back. You can maximize it, and you can get rid of it. You can show or hide the radio panel, give yourself a bit more real estate if you want. TNF we've already talked about. CWX, this is pretty cool. One thing that isn't easy to do with this is to plug a Morse key in when you're using it remotely. It is possible. There are things you can do to connect a key locally. And if you're using a Maestro, it's really easy because Maestro's got a key input. I can use a Morse key, but my CW from the computer is a lot better, and I still have to decode it by ear, which is fine. To me, that's the main thing. So I just used this. So you've got a whole bunch of quick keys, and you can adjust the speed of your CW. You can also just type in. Let me get away from here. Put it in the CW, and you can go. And I'm just transmitting CW. Or you can type in here. I think. No, I'm just trying to. I think if you unclick the live, and then just go send, it'll. Well, you type in here. VK6SJ, and then go send, and it'll send. So that's pretty neat. Really good in contesting and stuff like that. And then full duplex. What this allows you to do is you can put another one here. There we go. So sideband. So we've got two radios receiving. I'll just shift this to. Now we're in full duplex. I need to select this to a different antenna. Now when I key up the radio, I can still receive the other slice. So it's in full duplex. Normally wouldn't use it that close. You'd normally have a different band or something like that. Right, so we'll get out of full duplex and get rid of that. Yeah. So any questions on the Flex radio?
Well, I think it's a mightily impressive bit of kit there, Steve.
Yeah,
I'm sure it's given a lot of people a lot of grist for their mills and things to consider. I'd just like to take the opportunity to thank you. I'm going to have to scoot on.
Yep.
But thank you very much. I'll take this opportunity to thank you, and I'll throw it open to the group. But much appreciated, and good on you.
All right. Yeah. Sorry, I completely forgot about the time as well. So.
Oh no,
apologies.
I think it's fascinating, absolutely fascinating, and very generous of you to give up your time. So with that, I'll bid the group adieu, and I think John will still be around, or perhaps David you might be around as well. But there's a number of club members here, so I'll throw it open. Thank you very much.
No worries. Thank you for having me.